In this video, we're going to go through one other long, complex example on how to deal with perpendicular lines and parallel lines and the different things that we have covered in this section so far before we get into circles. All right. So the whole purpose of this is not to confuse you, but it's just to walk you through, some examples that you might need to break down. It looks complex, but hopefully as we go through this, you get that you create a muscle memory where you can actually start to break down questions and make them a little bit less complex as you go. All right, cool. So we have yet another Cartesian plane, and on this Cartesian plane we have a bunch of lines that are just going around, right? We have A, B, C, D, O, right? They all kind of come together to create a shape, right? But that shape consists of different lines. So you have the first line, which is AB, right? That is a straight line. It passes through point B, which has coordinates 4 and 7. So the x value of that coordinate is 4, the y value is 7. It passes through point C. The next line, BC, passes through point C. Point C, we don't know what the y value is, but we do know what the x value is. It's 8. Point C then comes all the way down to D and O, right? So O is your origin. But that line, we have actually been given the equation of that line, which is y is equal to 2y is equal to 3x. Right. And then we also have this little line here, AD, which is perpendicular to this, to line AB. But because AB is parallel to OC, right, it's also going to be perpendicular to that line as well. Right, so we can see that this is what's going on this complex shape, but let's just read the pieces of information that we have been given. Right, so line A passes through points O, D, and C. All right, so that's line A. So this is line A. Line B is parallel to line A, so this parallel line would be line B, and passes through points A and B, and we know the coordinates of point B. Shape ABCDO, which is A, B, C, D, O, right, is a trapezium with OB and OC as the parallel lines and AD as the perpendicular distance between those two parallel lines. So what we basically mean is this, right? So a trapezium is a shape where we have two parallel lines. We have this line and we have that line, right? And then essentially these two lines are going to be parallel. And then we have two lines connecting those two parallel lines. All right, so that is basically what a trapezium is. And what we're saying is this line AB and that line OC, those are your two parallel lines. And then, so that's going to be A, B, and then this is C, and then it comes back to O. So line BC is this line, and then OA is that line over there. And what they also say, or at least what I'm saying, is we have OD, which is this line here, which is the perpendicular distance between those two parallel lines. Okay, cool. All right, so that is essentially what that means. And then point C has x coordinate x, which we saw over here, right? So that is that complex question. So now let's break down the question. We're going to go question by question and see what is required of us in this problem. The first part says, calculate the equation of line B. So let's look at line B, right? Now, we know that line B passes through A. We know that it passes through B, and we know the point. We know the coordinates of point B, right? But we don't really know much else in this case, right? What we do know, though, is that line B is parallel to line A. And remember, when two lines are parallel, if line A is parallel, so I'm going to use these two lines to denote being parallel. If these two lines are parallel, then the gradient of A is equal to the gradient of B. So that's the rule for parallel lines. If two lines are parallel, it means they have the same steepness, right? So that's what gradient is. It's, like your steepness. So if the two lines are parallel, it means they have the same steepness, therefore their gradients are equal. Okay, so what then do we know what the gradient of A is, right? We do know what the gradient of A is because we know the equation of A, right? So we know that line A follows the equation 2y is equal to 3x. Sorry about that noise. which then translates to, if you divide both sides by 2, that's 3 over 2x, right? So now when it's in the form y is equal to mx, right? When you have this form, you can then tell that the gradient of this line A is positive 3 over 2. So when you now know that it's 3 over 2, then you also know that this is also the gradient of line B, right? So the two gradients are equal. Now the question is, why are we doing all this? Why did I have to find the gradient and all of that stuff? The reason is because in order for us to find the equation of a line, which is y is equal to mx plus c, the first step in calculating the equation of a line is you need to find the gradient, right? Since we didn't have enough information to calculate the equation of the gradient of this line B directly, we had to use A to help us out, right? But now that we have that gradient, which is 3 over 2, we can then get help from the point that we know, right? So what do I mean by that? So what I mean is the equation now becomes y is equal to 3 over 2x plus c. In order for us to find c, we're going to take a point that we know, which we know is 4 and 7. So when x is equal to 4, right, and y is equal to 7, we can now calculate for c, right? Put it into this equation, so this 2 cancels to go twice. 3 times 2 is 6. I'm just going to do this in like a quick, right? 7 is equal to 6 plus c. If you take this to the other side, it becomes 7 minus 6, which is 1. Therefore, your c value is equal to 1. All right, so your y is equal to 3 over 2x plus 1. So that's the equation of line B. All right, hopefully that makes sense, okay? So get the gradient, right? So get the gradient either by calculating directly, or if you know that it's parallel to another line, use that, right? So your gradients are equal to that line. Or if it's perpendicular, you use that product thing. And then once you have the gradient, you use a point to calculate the equation of a line, right? So that is always going to be the method that we follow when it comes to questions like this. All right, now let's move to question B. Question B says, calculate the equation of line AD. All right, now this is interesting, right? So grade line AD. The only thing we know about AD is that it passes through this point over there, right? And it's also perpendicular to this line, right? So if it's perpendicular, now we're going to do exactly the same thing that we did before. We're going to say, okay, the equation of the gradient, so let's just make this red this time. The equation of the line is y is equal to mx plus c. First step is always calculate the gradient. We don't know enough information about line AD to calculate that gradient. We don't have 2 points. So let's use the gradient of a line that we already know to help us out. All right. So we know that line OC is perpendicular to AD, right? So those two lines are perpendicular. So we can say, okay, line AD, so gradient of AD. Maybe let's stop by doing this. Line AD is perpendicular. So this is my signature for being perpendicular. Is perpendicular to line OC. This means that the gradient of AD multiplied by the gradient of OC should give us -1. Remember, this is the rule that we use for perpendicular lines. Okay. So what is that gradient, right? So the gradient of AD, which we're trying to find, multiplied by the gradient of OC, which we know is 3 over 2 from the last question. So multiply by 3 over 2, that's equal to -1. So if you divide both sides by 3 over 2, it's going to cancel this one on this side, and then this is going to show up on that side. If you throw that into your calculator, that's going to give you -2 over 3. And all that we've done so far is calculate the gradient, right? So we're still not done, right? So the equation now, let's move back to black. Y is equal to m. Now we know what that m is, -2 over 3. So y is equal to mx plus c. So now we can say, okay, I know the gradient right? I know the, do I know a point, right? So how do I then find what this C value is? Now, you can do this one of two ways. We can say, okay, let's look for a point that it passes through. So we can see that it also passes through point A. We can look for the coordinates of point A, all right? Or we can say, okay, remember your C value is your y-intercept, right? If this is my y-intercept, it means it's the point at which it crosses this line. So what is that point? We actually already calculated it from before, because the y-intercept of line AD is the same as the y-intercept of line AB, because they cross the y-axis at the exact same position. So the C for this line is actually going to be the same C for this line as well, which is positive 1. So this equation is actually going to be y is equal to negative 2 over 3 x plus 1. Or you could have said, okay, I know that line AD passes through point A. What are the coordinates of point A? The coordinates of point A, the x value is 0 because it's on the y-axis, right? So your x value is 0. Your y value is 1 because we know that that's the coordinate of that point of your y-axis. So you could have just come here and then plug that in, right? So your x becomes 0. Let's just do that. Your y is 1, 2 over 3. Your x is 0 plus c. So this cancels out. So that means the only thing you're left with is c is equal to 1. So it basically gives you the exact same answer. All right, so we've used perpendicular lines to calculate the equation of one line. We've used parallel lines to calculate the equation of another line. So those are the two answers, the two questions, the first two questions in this problem. Okay, right. Now let's look at part C. Calculate the coordinates of point D. Right? Now point D, what's the significance of point D? Point D is the point of intersection between AD and OC. All right? So, right, point D is the intersection between line AD and line OC. And what do we do when we want to find the coordinates of a point of intersection? We're going to take the two lines that are intersecting, which is AD, right? So what's the equation of line AD? We've just calculated that. That's y is equal to negative 2 over 3 x plus 1. All right. And we also have the second line, which is OC, right? That equation is y is equal to, I think it's 3 over 2 only, 3x over 2, yeah. 3 over 2x, right? So in order for us to find the x value, what we're going to do is we're going to say, okay, a point of intersection means at that very same point, your y values are the same. So we're going to say the y value of the first line is equal to the y value of the second line. So then we take the y expression from this first one, which is negative 2 over 3 x plus 1. That's equal to the y expression of this one, which is 3 over 2x, right? Essentially, we are trying to solve for a simultaneous equation. That is the rule when it comes to lines of intersection, points of intersection rather. We're saying at a point of intersection, your two graphs have the same x's, they have the same y's. So we can actually just join these two, create one equation so that we find what that one x value is, what that one y value is. So we solve the equation simultaneously. All right, I hope that makes sense. All right, so to solve this, we're going to take this expression, we're going to move it to that side. So we still have the positive 1 on this side, but on the other side, it's going to become 3 over 2x plus 2 over 3x. Put that into our calculators. So that's 3 over 2. Right, so these questions have been coming out very ugly because I come up with them out of my head. So maybe the numbers sometimes are not the prettiest, but you know, we keep on pushing anyway. All right, so we have this. So we divide both sides by 13 over 6. It's going to cancel on this side. So now what you have left on that side is x is equal to 6 over 13. Right, so not the prettiest answer, but again, right, as long as the answer is correct and as long as you can see the procedure that we're following, then we are good to go. All right, so that's your x value. But remember, the question is asking for coordinates. And the moment you see coordinates, it means a coordinate has an x value and a y value. So don't just stop at the x, also find the y. All right, so our y value, we can use one of the two equations, right? I'm going to use the easier one, 3 over 2x. 3x over 2 rather. Right, so that's going to be 3 multiplied by this value, 6 over 13. You divide that by 2. That answer is times 3 over 2, 9 over 13. Right, so again, it's not the prettiest answer, but yeah, we work with what we have, right? So that's your x coordinate and that is your y coordinate. Now, just to give ourselves just a little bit of peace of mind, what we're going to do is we are also going to come back here, right? Because we've just used this equation to find y. But remember, that equation is also supposed to give you the same y if you plug in the same value of x. So let's just put that value in to make sure that our answer was correct. All right, so negative 2 over 3 multiplied by the x value, which is 6 over 13. Plus 1. If you punch that into your calculator, you also get 9 over 13. Right, so both equations gave us 9 over 13, at least at this step. We didn't really make a mistake. So I think we can move on at this point. So the coordinates, the answer is, remember your coordinates are always supposed to have two values. Your x value, which is 6 over 13, and your y value, which is 9 over 13. Both of these are positive values. As you can see here, it's like a small positive value over here in the x direction, a small positive in the y direction. So graphically, it kind of makes sense. Okay, so that is part C. And I think we have one more question. Part D, calculate the equation of a trapezium, of the trapezium ABCDO. Right, so we have the trapezium and I had drawn this just to show what, I'm wondering if I can copy this. Can I paste it here? Yes, I can. All right, let's just enlarge this a little bit. All right, so we have this trapezium over here, right? Now, the equation of a trapezium, the area of a trapezium I said the equation of the trapezium. This is supposed to find the area of the trapezium. Okay, the area of the trapezium in general, right? So it follows the formula. The area is equal to A plus B over 2 multiplied by h, right? So you add A plus B multiplied by h. Now the question is, what's A and what's B? Your A and your B are the two parallel sides of the trapezium. Your h is the perpendicular distance separating those two. So as long as we have the two parallel sides, we can add them and divide by 2 and then multiply by the perpendicular distance here. So now going back to our graph, what are those values? Those values, maybe let me also copy the full thing here, so we don't have to keep coming up and down and up and down. All right, so let's just take this down here a little bit. Okay, so remember we're following this equation over here. Okay, so our parallel lines A and B are line AB and line OC. So the equation becomes area is equal to, I'm going to rewrite the equation, A plus B divided by 2 multiplied by perpendicular distance. Your A is line AB. Your B is line OC. You divide that by 2. You multiply it by h, which is line AD. So that means we need to find the individual lengths of these lines, right? So this is going to be a little bit tedious, but let's just talk about this formula once, and then from there, we'll just start applying it directly. So if I have 2 points, in order for me to find the length of a line, if I have a point which has its x and its y, and I have another point which has its x and a y, right? So I have point 1 and point 2. In order for me to find the length of the line, which we'll call r, r is going to be equal to the square root of, so you find the difference in your x's. So your x2 minus your x1, you square that, and then you add the difference in your y's, y2 minus 1y squared, and you square root that answer. So this is the formula we're going to use. I'm going to use it a little bit quickly because the video is really going a little bit long. All right. But remember, I'm just following this formula. All right. But I'm going to follow it for each of the lines that we need to find. We'll start off with line AB. We say, okay, line AB is between this point, which has this x value, x1, that x value, that y value, y1. And then you also have this point over here, which is 4 and 7. So what we're going to do is we're going to say length of AB is equal to the square root of, calculate the difference in the x's, right? That's going to be 4 minus the x value of that point, which is 0. I'm hoping this isn't too confusing. Plus difference in your y's, right? So the y value of that point, the y value of this point. The y value of that point is 7. The y value of this point is 1. So we're going to say 7 minus 1 squared. And then you find the square root of this. Punch this into your calculator, 4 squared plus 6 squared. The answer, I'm going to write this in exact form. That's 2 root 13. All right, so that's your first one. Fantastic. We've gotten this first one out the way. Perfect. Now we move on to OC, right? Now OC is a bit tricky, right? Because we do have, remember again, between those 2 points, we still need to know what are the coordinates of this first point. This point is at the origin, so that's 0, 0. That's easy. The tricky thing is with your C, because we know that this point has an x value of 8. But what's the y value? Right? In order for us to find the y value, we can say, okay, we know the equation follows y is equal to 3x over 2. We've just rearranged this equation again. So when x is equal to 8, your y value is going to be 3 times 8 divided by 2, which is 4, so that's 12. So your y value over here is going to be 12. So that's your second point. So now we have these 2 points. So now we can go into our equation and say, okay, the length of OC is equal to the square root of the difference in your x's is your 8 over here. The x value of that is 0. So that's going to be 8 minus 0 squared plus the difference in your y's. The y value of that point is 12. The y value of this point is 0. Squared. So you find the square root of this. Punch that into your calculator. 8 squared plus 12 squared. 4 root 13. We have a lot of 13s in this problem. Okay, now we found the 2 lengths that we were looking for to apply in this equation. So we have OC. Now we need to look for AD, right? Now, again, we're asking ourselves exactly the same question every time, right? So AD is going to be between 2 points. The first point is this point A, which has x value 0, y value 1. Point D has, now we have to copy these from the last one, 6 over 13 and 9 over 13. So your x value is 6 over 13, your y value is 9 over 13. So now we can now apply the same formula for the third time. Length of AD is equal to the difference in your x's, right? It doesn't really matter which one you start with. So you can say 6 over 13 minus 0. Remember to square that. Plus the difference in your y's. So we take the y for this point minus the y for that point. That's 9 over 13 minus 1. And you square that, and you find the square root of this answer. Right, so this one, I'm sure it's not going to give us the same kind of, pretty answer, but let's see what it gives us. 9 over 13 minus 1 squared. Okay, I'm going to write the exact value that it gave us. 2 root 13 over 13. Perfect. So now we have everything we need in this formula, right? So we can now apply area is equal to the length of AB, which is your first parallel line, plus the length of OC, right, which is your second parallel line. You divide the sum by 2. Once you get that answer, you're going to multiply by the length of AD. So let's put that into a formula. Let's plug in our numbers. So the length of AB is 2 root 13. Plus the length of OC is 4 root 13. Divide those by 2, and you're going to multiply by 2 root 13 over 13. Okay. So let's see what we get there. 2 root 13 plus 4 root 13 divided by 2. You multiply that by 2 root 13 over 13. Wow, you get an answer of 6. That's okay. That was a mistake. I don't know how that ended up being an exact value, but okay, I'll take it. But essentially that's how you solve that problem. So the last two videos that we've basically done are more complex examples where you have to break it down and you have to follow through a lot of different steps and you have to kind of think outside the box. Unfortunately, with AS levels, that is what you need to practice, right? You need to practice that application where, yes, you know how to calculate the length of a line, that's fine. But what if I give you this trick or that trick, right? So these kinds of videos where, yes, it's long. I understand it's long and it may look complex, but it's teaching you how to break down a very complex problem. So by the time you do this and then you do more exam problems, hopefully you have grown the skill to break down questions based on the information that you know already. Right, so let me stop this here. I hope this was helpful and I hope I haven't scared you away, and I hope I'll see you in the next video.